Today we're going to talk about solving quadratics using square roots. So we talked about how to use square roots and how we can have a positive and a negative square root for all positive numbers. Now we're going to use those square roots to solve quadratic equations in the form of ax squared plus c equals 0. So first, we have to isolate the x squared. We need to get rid of that c and any kind of a that's in front as a coefficient. So what we're going to do is isolate the x squared onto one side of the equation to get x squared equals d. Why d? Not really sure. That's just the way this works. So then, to solve, just to find the actual x value, we're going to be doing the square root of each side. So looking at this chart below, what's really happening is we're going to start with something like this in a quadratic form with the ax squared plus c equals 0. We would subtract the c from both sides, divide by any a that's there to get one of these possibilities. When d is greater than 0, we're going to have two answers. Remember, when I take the square root of a positive number, I would have a positive and negative answer. If d equals 0, when I have x squared equals d, so if x squared equals 0, I'm only going to have one answer because the square root of 0 is 0. If d is a negative number or less than 0, then this is where we would say there is no real solutions because I can't take the square root of a negative. So let's just take a look at how some of these would work. So in this first example, we have ax squared plus c equals 0. So the first thing that I would do is I would be adding 27 to both sides. When I add 27 to both sides, I would get 3x squared equals 27. Then I would divide by 3 to get x squared equals 9. And then I would take the square root of both sides, and remember, plus or minus 3 is going to be my answer there because we have both positive 3 and a negative 3 when I take the square root of 9. Some of us will be really excited that there's no graphing involved here. This was just solving an equation. Looking at the second one. So again, I need to isolate the x squared. So I'm going to add 10 to both sides. When I add 10 to both sides, I get x squared equals 0. Well, when x squared equals 0, if I take the square root of both sides, there's the x I want. There's only one answer for this one, x equals 0, because there is no such positive and negative 0. And on the last one, we would subtract 11 first. I get negative 5x squared equals 5. Then when I divide by a negative 5, notice what's happened. We get negative 1. Now I can't take the square root of a negative number. There is no number that times itself gives me the negative. So that's going to tell me that there are no solutions. Okay, so you isolate the x squared. If the d, once you have it isolated, is positive, there are two answers. If it is 0, there's only one answer, and the answer is 0. And if there is a negative number, there is no solution. So then we have a problem like this one. We have x minus 1 squared equals 25. Now certainly I could use my FOIL and do out x minus 1 squared, which is a lot of work. When you look at this one, I see a perfect square on both sides. So to solve this without thinking of graphing, if I just go right to square roots here, I'm going to get x minus 1 equals 5 and also negative 5. So we've got to remember that. It's not just 5. So what I do here is I'm just going to take x minus 1 equals 5, x minus 1 equals negative 5, add 1 to both sides, x equals 6, add 1 to the other side here, x equals negative 4. So the answers I get for this one are both 6 and -4. It's just important to remember here that just by saying take the square root of 25, we don't fall into the trap of saying it's just 5. This is not a geometrical kind of question where you'd say, well, there is no such thing as a -5 in that. There is no such thing as a negative happening in the past for time. This would be one that you're just taking the square root of a number 25, so there are two answers, and you need to consider both. So next we're going to talk about doing an approximation of one, but they're not always going to be perfect squares. If they're not perfect squares, we're just going to use a calculator for the most part. You want to notice that we are rounding to the nearest hundredths place. So for this one, we would just add 13 first, right, to move the 13 to the right-hand side. I'm going to get 4x squared equals 28. And divide by 4. X squared equals 7. Now, clearly we can do it because it is a positive number. We will get two solutions, but x squared is a perfect square, 7 is not. So I'm going to take the square root of both sides, and I'm going to get x equals the plus or minus square root of 7, which, with a calculator, is approximately 2.65 rounded to the hundredths, or negative 2.65. Again, rounding to the nearest hundredths. If it was rounded to the tenths, I would obviously adjust or whatever they were rounding to. Okay, next we're looking at the tank that we're trying to reach in and touch, probably stingrays or something like that, it looks like. Has a height of 3 feet. The length is 3 times the width. So on this one, I'm just going to kind of put in a few of my own little notes. So I'm going to say the width, I'm going to call x. That would mean the length would be 3 times that amount, or 3x. Okay? Now volume, this is a rectangular prism, so volume is length times width times height. The volume we know, they give it to us as 270 cubic inches. The length is 3x. The height is x. And the width was x, the height is 3. So when I multiply that together, that's going to give me 9x squared equals 270. Divide by 9. X squared equals 30. To undo x squared, take the square root. It's not a perfect square, so I'm definitely going to grab my calculator. And in this case, we wouldn't be taking the negative because we're talking about a dimension. We would only be taking the positive. And the square root of 30 is approximately 5.5 feet. So that's the width. They also are asking for the length. And the length is simply 3 times that amount, or 16.5 feet. Lastly, for example 5, we're going to rearrange a formula and then evaluate it based on the information that's given. So the area of an equilateral triangle with the side length of S, the area of this type of a triangle, is given with this crazy formula here. They want us to first solve for S. So that's the first part. So remember, when I'm using one of these and I'm solving for S, I use my operations backwards to kind of get to the one that I want last. So there's a couple of different ways I can do this. So the very first step I might say is I might just say, let's move the 4 that's in the denominator by multiplying both sides by 4. That'll get it to the left-hand side and eliminate it over here on the right. So now I would have 4a equals the square root of 3 times s squared. Then we would take care of this division to undo the square root of 3 times s squared. Now I'm just going to leave all these symbols right inside this for now. I'm not going to turn that into the crazy decimal that it is. But now I'm down to s squared. Then to undo this, I'm going to take the square root of both sides. And again, on this one, I'm really not going to focus on a negative answer. And the reason is because we're talking about a side measurement. I'm certainly not going to get a side measurement that's negative. So I'm only going to focus on the square root that's the positive of 4 times the area of that shape divided by the square root of 3, and that whole thing is the square root. So there's the first part. That's just rewriting it. So then we want to approximate the side length of the traffic height that has an area of a 390. So basically now I'm going to use the area of 390. And I'm going to plug in 390 where I see the area. Then I'm going to let my calculator do the job for me. So what I'm going to do is multiply 4 times 390 divided by the square root of 3. Once I have that, I simply take the square root, and the answer is approximately 30. And so the answer is approximately 30 inches, because we're dealing in a sign that is in inches. So that was just another way of kind of doing a couple of things that we've done over the past. First, rewriting the formula for a different variable, so we did to the s, then plugging in what we had to find the missing piece. So a lot of it's going to come down to perfect squares. If they're not perfect squares, your calculator is certainly going to take part and help you out. You're still really using the same solving equations that we've used throughout the entire year. We're using inverse operations to undo things to get to your final answers. Remember, if you have your x squared equaling a positive number, you will have 2 solutions. If it equals 0, you have 1 solution. The answer will be 0. And if you have it equaling a negative, you have no real solutions. Hope this helps. Please let me know if you have any questions, and we can go from there.